Alright, let's look at the practice exam 2, problem number 2. Alright, so we have this rational function and we want to find all these limits and asymptotes. Alright, let's look at the part A. Alright, so we want to take the limit of this function as x approaches positive infinity. Alright, so let's do that. Alright, so this is going to be equal to limit as x approaches infinity. Right, I'm going to just write down the function. So it's 2x squared plus 3x minus 2 over x squared minus x minus 2. Right? Then in order to evaluate this limit, it's probably easier to do this trick. I'm going to look at the highest power on the bottom, which is x squared, right? Then I'm going to divide top and bottom by x squared. So I'm going to multiply bottom by 1 over x squared, same thing as divide by x squared, and do the same thing to top. Right, then you see that once you've done that, you know exactly where everyone's going. So it's a limit as x approaches infinity. Right. Then let's say 2x squared divided by x squared would be just 2. Right. 3x divided by x squared would be 3 over x, because one of the x's cancel out. And negative 2 divided by x squared would be negative 2 over x squared. Right? Let's see, x squared divided by x squared is 1. And negative x divided by x squared would be negative 1 over x. Negative 2 divided by x squared would be negative 2 over x squared. Alright, then you can see that as x approaches infinity, so x is going to be a huge number, you can see that the 3 divided by a big number is very close to 0, and 2 divided by a big number squared is still going to 0, and a 1 over a big number is going to approach 0, and same thing, 2 over a big number squared is going to still approach 0. Right? So you can see that there are only a couple numbers left, 2 on top and 1 on the bottom. So 2 over 1 is going to be equal to 2. Right? So that's that. And let's look at the part B. Right? So x is approaching negative 1 from the right. Right? So first thing I'm going to do is I'm going to factor out the top and bottom. So let's do that. So we have a limit, right, as x approaches negative 1 from the right. Right, and you have, right, factor out the top guy. Let's see, so you have factors. Right, so we have to make a 2x squared, so I think it's going to be 2x and x. Right, then let's see, we have to get negative 2, so it's 1 and 2, so I would say negative 1 and a plus 2. Right, let's see, negative 1 times 2 is negative 2, 2 times 2 is 4. Plus negative 1 gives you positive 3, so that's good. And on the bottom can be factored out as, right, so we have to make x squared, so I will put the x here and x there. And we have to get negative 2, so it's probably 1 and 2. And we have to get a negative sign, negative 1, so it's going to be negative 2 and a positive 1. Alright, so we have that. Right. Unfortunately, there isn't going to be any cancellation, but in this form, it's easier to evaluate. Right, as x approaches 1, right. Let's see where everyone goes. X approaches negative 1. Right. So this guy goes to, right, negative 1 plus 1, so it's 0. But whenever you have 0, you have to be careful to indicate either positive side from the negative side, right? So x is approaching -1 from the positive side, so you can think of x as a slightly larger than -1. So like you can think of a negative 0.99 or something like that. Right, 0.99 plus 1 is slightly positive, so I indicate that it's going to be slightly positive. All right, then do the same thing, -1 minus 2, so this one approaches -3, right? And negative 2 times -2, so it's going to be -3, so this guy approaches -3 as well. Alright, this guy, -1 plus 2, so that's going to be 1. Alright, then you can see that here we can cancel -3 and -3. So what's left is really 1 over 0 from the positive side. Alright, so which means that, let's see, whenever you have non-zero divided by 0, so it's going to be a huge quantity, so infinity. And top is 1, which is positive, divided by positive, so sign is going to be positive. Alright, so this limit is going to positive infinity. Alright, so part C. Right, it's very similar, it's just that the x approaches 2 from the left hand side, so let's just do the same thing. So its function is still be the same, so x approaches 2 from the left, so you're going to have same factors, 2x minus 1 times quantity x plus 2, and over x plus 1 times x minus 2. Right? Then let's see, so it's going to 2, so this guy goes to 2, 2 plus 1, so it's going to 3. Here this is going to 2 minus 2, so it's 0. Right? So x is approaching 2 from the left, so this is going to be slightly smaller than 2, so you can think of it's 1.99. 1.99 minus 2 is going to be slightly negative. Alright, and you have a 2 squared minus 1, so that's going to go approaches 3 as well. And 2 plus 2 is approaching 4. Alright, so you can cancel 3 on top and 3 on the bottom. What's left is 4 divided by 0 from the negative side. Alright, again, non-zero divided by 0, it's going to give you infinity, and a positive divided by negative is negative. So this limit goes to negative infinity. Alright, then based on part A through part C, we can find asymptotes. Alright, so let's look at the horizontal asymptote. Right, so in order to find horizontal asymptote, you have to look at the limit at infinity. And the part A says that limit at infinity is equal to 2. So this tells you that there's a horizontal asymptote, which is y equals 2. Right, but this number 2 came from this right here. Right, this is the answer from part A. Right, but to be sure to give an equation for a horizontal asymptote, since horizontal asymptote is a horizontal line, so it makes sense to give it an equation, not the value. Don't say horizontal asymptote is equal to 2. That would be incorrect. Alright, so looking at part B and also part C, we know a couple of vertical asymptotes. So vertical asymptotes, right? They are All right, since function blows up and blows down, let's see, having a blow up, blow down behavior at x equals -1. So you can see that here, -1, and also x equals 2. So the vertical asymptotes are x equals -1 and also x equals 2. Right? Again, these number came from here, so I'm gonna just do this, and 2 came from there. Right? So the vertical asymptotes, again, you need to give equations, since vertical asymptotes are vertical lines. All right, that's it. I hope that this was clear.